All right, so for homework last night, we had the other half of what we did in class yesterday. So yesterday we saw the trig identity, secant plus tangent equals cosine over 1 minus sine. Now, again, in class, what we did was we worked with the right-hand side, and we got it to look like secant and tangent. What I asked you to do for homework was to only focus on the left-hand side, the secant and the tangent, and make it look like the right-hand side. All right, so with secant and tangent, one of the first things we can do is we can change them using our quotient rule. Secant is also 1 over cosine. Tangent is sine over cosine. Okay, so we used a reciprocal rule and a quotient rule. Right, secant gives us that, tangent gives us that. Now, with this, well, we're adding fractions, and we already have a common denominator. So I'm going to have 1 plus sine in my numerator, and in my denominator, we just have the single cosine. All right, remember, when we're adding fractions, the denominator doesn't change unless we have to change it for the common denominator part. Okay, so just don't get confused there. Right, so now, okay, it looks like I kind of got things going on here that look similar, right? But I need the cosine to be in the numerator, and I need to change the sign there. So I'm just going to rewrite it down here so I have some room. Okay, so I want this, again, to look like this up here. So one of the methods we can use when we see something like this is we can use the conjugate like we did yesterday. All right, so I can multiply the numerator and the denominator by 1 minus sine of x. All right, so in the numerator, when we do that, okay, we get 1 minus sine squared. Right, and after I FOIL, the middle terms cancel out, and I'm left with 1 minus sine squared. And in the denominator, what I'm going to do is I'm just going to keep them separate for now. Well, okay, so we're getting close. I have the 1 minus sine x, but I got some extra things in the denominator, and that's not what I want there. But here I have a sine squared and a 1, right? That's a good sign. My Pythagorean theorem, my Pythagorean identity, says that sine squared plus cosine squared equals 1. That's not exactly what I have here, so let's manipulate this so it looks like this. I can subtract sine from both sides. And I see that 1 minus sine x, I can substitute that for cosine squared. So this up here, the numerator becomes cosine squared, and then that's all over cosine 1 minus sine. So we're almost there. I have a cosine in the numerator now, but I have too many cosines. But here I have a cosine squared, or cosine times cosine, and down here I have a single cosine. So we just use our properties of fractions, and we can simplify. All right, I take out one of the cosines here, and I take out one of the cosines there. In the numerator, I'm left with cosine x, and in the denominator, I'm left with 1 minus sine x. And that is exactly what we were looking for. Right. So again, like I've been saying, you may have taken a different approach. Okay, you could have multiplied by cosine, top and bottom here. And then you have a cosine squared in the denominator, And then you can go the other way. You can replace cosine squared with 1 minus sine. Then you can split that up. Okay, so if you did a different version, if you took some different steps along the way, but you still ended up with the right side, cosine x over 1 minus sine x, that's what we're looking for. All right, so there can be more than one way to do this. Any questions about the homework there? Okay, so today we'll see how much time we have, but might be the last day we're talking about trig identities. I know you guys are going to miss it so much, but you know, we do have to move on. But there's one more example that I want to show you. So let's. Okay, so again, we're going to verify. Okay, so what I want to show you here is that very rarely, but sometimes it is required for us to work with both sides of the equation. So what I'm showing you, we can do it only with working with one side, but it makes it a little easier if we manipulate both sides. All right, so let's take a look at, make sure I write it down right. Okay, so here we're going to deal with cotangent squared over 1 plus cosecant equals 1 minus sine over sine. So both of these are they're not simplified either side, right? I don't have just a single trig term on one side. This side looks a little nicer because it's just sines, right? But they're both fractions. They both involve, you know, other operations, plus 1, minus 1, whatever, blah, blah, blah. All right. So first, we're going to start with the left-hand side because that's a little more complicated. So we can do some simplification there. So cotangent squared, right? We have one of our Pythagorean identities that tells us, let me make sure I get it right. Okay, yeah. One of our identities says that 1 plus cotangent squared equals cosecant squared. So I can say that cotangent squared equals cosecant, oops, I forgot the theta there. And I'm spelling it wrong. Cosecant squared minus 1. All right, so I'm going to use that, and I'm going to substitute that up here. And I just realized I'm probably going to run out of room, so I apologize. So the cotangent squared is going to become cosecant squared minus 1 over 1 plus cosecant theta. So this one, you know, after we change it using the Pythagorean, usually what we're going to want to do is use our factoring skills after that, right? This is like saying x squared minus 1. So this isn't always apparent right away if I see cosecant squared minus 1 or tangent squared minus 1 or whatever it is, right? But we can break this up, right, to the perfect square. So I can split it to cosecant minus 1 times cosecant plus 1. So with this, I have like terms in the numerator and denominator. Now be careful. They are in opposite order. But because it's addition, the order doesn't matter, right? I can just swap these two, and I can say cosecant plus 1. All right. If it was minus, then the order would matter, right, where the negative goes. But those eliminate each other. And right now, I'm left with cosecant minus 1. Son of a gun. All right. So if I kept going in this way, my task would be to make cosecant minus 1 into 1 minus sine over sine. So that's a little tricky. I can show you how we do it, but let's now take a look at the left-hand side. I have 1 minus sine over sine. Now, this is another tricky part that isn't always apparent right off the bat, right? You may not see it right away, but if we have a fraction, and in the numerator, we have different operations going on, but in the denominator, we only have one thing happening. So here, our sine. We can split this as two separate fractions. So I'd have 1 over sine minus sine over sine. If I simplify this, 1 over sine is cosecant minus, and anytime we have something over itself, that's always 1. All right, so we got them both to match up. All right, so you are able to work on both sides if it's absolutely necessary, and if you're in a position where you can't see any further steps. Okay, but I do recommend against it because it can get a little confusing, especially, all right, this work is all the left side and this work is the right side, so you might have to make it look nice, keep it in columns. All right, but like I said, I will show you. I don't need this part necessarily, and I could keep working with this, right? So if I wanted to keep working with this, cosecant is 1 over sine. So if I have 1 over sine minus 1, and I want to actually subtract them, I need a common denominator. So this 1 would become sine over sine. And then when I combine these, I get 1 minus sine over sine. Okay, so it is possible to get to that final solution just using one side. But this part here is not always, you don't see that right away, going from cosecant minus 1 to this. All right, but there I just showed you real quick that there are at least two different ways to verify that this is true. Right, we verify. Okay, any questions?
No. Mr. Murray.
What's up?
How are we able to tell when we need to work on both sides?
So in all honesty, you can work on both sides in any time. But like I said, it can get confusing if if you're working on the left side and then, oh wait, let me go to the right side, and then, oh wait, I'm kind of somewhere on the right side and let me go back to the left side. So you just got to make sure you're organized if you're doing it that way. But my general rule is if you're absolutely stuck and you can't figure out a way, right? So if I'm looking at this and cosecant minus 1, it's like, well, I can't make it into a Pythagorean because I can't multiply by anything because it's not a fraction. You know, so right here, maybe I'd be stuck. So I'd say, all right, let me manipulate the right side and see if I can get to this point. Okay, you may start manipulating the second side and end up nowhere near the cosecant minus 1, but you may end up with, you know, actually that would be really hard to go from this to that. That'd be difficult. But yeah, it's kind of like a trial and error thing. And that's what kind of stinks about all of this is that, you know, what we're going to be doing, I'm not sure, we only got 10 minutes left today, but our next lessons are actually solving equations. Okay, so that's a little more straightforward. You know, you use the opposite operation, right? If you're adding to get rid of it, you subtract. If you have a sign to get rid of it, you use inverse sign, right? Sign to the negative first. With this, it's a little more abstract. Okay, so yeah, so if you're working on one side and you're absolutely stuck and, you know, your brain shut down and you can't go any further, then start working with the opposite side and see if you can meet in a middle ground. Right, but there really is no rule to, you know, when you can or cannot work on both sides.
All right, thank you.
You're welcome. Hmm. Yeah, I don't think we have enough time for me to get started.
Shall we do another example?
Yeah, sure. Let's do one more. We'll wrap it up with one more example. Oh, there's some real crazy ones here. Oh wow, we already used a lot of my notebook. I was missed out. Man, there's some crazy ones. I don't know if I have enough time for that. All right, let's look at this one because now we have two variables. Actually, do we know that rule yet? Yeah, I think we're good. All right. So here I have cosine x minus cosine y over sine x plus sine y plus sine x minus sine y over cosine x plus cosine y equals 0. All right, so obviously there's only one side we can work with. I can't take 0 and make it into that convoluted part. So the one thing I'm noticing is, well, they're asking me to add fractions, right? So in order to add fractions, we need common denominators. Since these two denominators don't share anything in common, okay, for now I'm just going to remove the 0 just to give us some room. We multiply by the other denominator, right? So this side I'm going to multiply by cosine x plus cosine y, cosine x plus cosine y. This side I'm going to multiply by sine x plus sine y, sine x plus sine y. All right. So I'm going to have one denominator, and I'm going to keep it separated. So I'm going to have cosine x plus cosine y times sine x plus sine y. So that's my one single denominator. I don't think I need all that, but now my numerator, something interesting happens. When I multiply all of this, okay, I get a cosine squared x and a cosine squared y, and because this is positive and that's negative, everything else cancels out. So I have cosine squared x plus cosine squared y plus, and then the similar thing happens over here, sine squared x plus sine squared y. All right. So what can we do next? So with either of these, okay, we can use Pythagorean theorem, right? But I don't want to change everything because then, you know, I'd be dealing with sines and cosines again, right? So I'm just going to change one of these. Let's do the cosines. So because sine squared plus cosine squared equals 1, I can say that cosine squared equals 1 minus sine squared. Okay, so I'm going to replace this for both of those. So I'm going to have 1 minus sine squared of x plus 1 minus sine squared of y plus sine squared of x plus sine squared of y. And again, I didn't touch the denominator. Cosine x plus cosine y, sine x plus sine y. Now here, I get a 1 and a 1, so that adds up to 2. But then my sines cancel each other out. So I have 2 over cosine x plus cosine y times sine x plus sine y. And now I'm stuck. I picked a really tricky one. And we're almost out of time. So what I'll do is I'll work on this on my own. We'll wrap it up real quick tomorrow. I should have probably picked one that I could figure out. We'll wrap this up tomorrow and then we'll move on. I don't want to spend too much more time on trig identities. We've done a lot of them, mostly this week. All right, so my mistake for choosing one that didn't work. Well, not it didn't work, but I got to still work on it. All right, guys. Yeah, no homework tonight. Yeah, you've had homework the last 3 nights. So we'll just meet up tomorrow. I'll finish this, and then we'll start a new lesson. Have a good day, and I'll see everybody tomorrow.
Bye, Mr. Murray.
I'm almost done copying this down.
Okay, take your time.
All right. Thank you. See you tomorrow.
You're welcome. Bye-bye.